Today we're going to do homogeneous equations. And I write D, it means differential equations. Homogeneous differential equations. First, you have to know what a homogeneous polynomial is. These are polynomials where if you add the exponents of x and y, they always give you the same thing. So, for example, if you have 3x to the 5th plus 4xy to the 4th plus 3x cubed y squared plus y to the 5th. That's an example of a homogeneous equation because, for example, here, x, y to the 4th. What's the total sum of the exponents? X to the 1st power, y to the 4th power. If you add 1 plus 4, you get 5, right? 3 plus 2 is 5. This is 5. That's 5, okay? If you see that all the exponents add up to the same number, then you say this is a homogeneous polynomial of degree 5. Now, what is a homogeneous differential equation? Well, homogeneous differential equation is a differential equation that has the form pxy y prime equals to qxy, where pq are both homogeneous polynomials. Now let me give you an example, e.g. suppose you have of same degree, So for example, if you have 4xy y prime equal to x squared plus 2y squared, then you can see that this is a single polynomial with the total degree 1 plus 1, which is 2, right? So this is a homogeneous polynomial with degree 2. That's degree 2, that's also degree 2. So you know that both sides are homogeneous polynomials of the same degree. Okay. Now, in such a case, you can divide by this p to turn into another format. So let me show you how it works. If you divide by xy, if you divide by 4xy, y prime becomes x squared plus 2y squared over 4xy. And I want to divide top and bottom by x squared, or in general case, just divide by x to some power, whatever the order, the total order of that polynomial is. So if this was 3, 3, and x and y squared, so that these are top and bottom are both homogeneous polynomial of degree 3, in that case I would be dividing top and bottom by x cubed. Okay, so just divide by whatever order it is. Then the right side transforms in the following way. X squared divided by x squared is 1. Y squared divided by x squared, that's y squared over x squared. And 4xy over x squared. Well, one of the x's will cancel with the x's, right? So what would you get? You get 1 plus 2. You can rewrite this as y over 2 squared. Y over x, not y over 2, sorry. y over x squared. And bottom here, x cancels with one of the x's there, so you end up with 4 times y over x. And as you can see, you've turned the original homogeneous equation, differential equation, into a differential equation which is a function of y over x. Okay. So this right side looks like if you had f of x equal to 1 plus 2x squared over x. It's just like taking this function and replacing x by y over x, right? So if you took that function, then you would get this right side, okay? And that always happens, which provides us with the second definition of homogeneous equation. So another definition of homogeneous differential equation is that you have y prime equals the function of y over x. If you can turn your differential equation into that format, then it's called homogeneous differential equation. And by the way, this is the definition most differential equations books take. But I think it's easier to understand in this format. So I like this definition more because here's a homogeneous polynomial, another homogeneous polynomial, and you get that. Okay?
What's that? What did you write in like the bottom right corner?
Here?
Yeah.
Okay, let me write this again, okay? So what I'm trying to say is that this one is equivalent to, if you had f of x equal to 1 plus 2x over 4x, then think about what f of y over x would be. Right, 1 plus 2 times 4. See, what I'm doing is I'm copying this definition over here. And what goes in here and there if I put y over x here?
Y over the x value.
Yeah. Okay, so you see that this right side can be thought as a function of y over x, right?
That equals
Yeah. So, and I did this so that I can convince you of this second definition of a homogeneous differential equation. Homogeneous differential equations are differential equations which can be written in this form. Yes?
So why did you divide by x squared? Just because the power of each?
The reason for dividing by x squared will be discussed later.
Okay.
Okay, yeah. For now, I divided it so that I can sell this second definition, that this is equivalent. Actually, to tell you the truth, the second definition is more general than the first one. There are differential equations which can be put in this way, but it can't be written that way. Okay, so this is more general, and that's why most books take this as their definition of a homogeneous differential equation. Okay. All right. Anyways, that was the definition. But how do we solve such a thing? Well, the way we solve this is once you've managed to write down the differential equation, let me copy it again because it's hard to read from there. Once you've succeeded in writing down the differential equation as a function of y over x, then it's kind of natural that you want to do a change of variables with u being equal to y over x.
Wait,
Yes?
is there squared?
Oh, I forgot the square. Thank you. There was a square here.
Over here too.
Here. Okay. All right. So there should be a square here. Bigger. Right. So it's kind of natural that you want to use u equals to y over x to solve this differential equation, right? Then, because if you do that, then this is just 1 plus 2u squared over 4u. That's much simpler, right? But if you do that, then immediately there's a question about what to do with y prime, right? So the method for solving such a thing is first use this substitution, but then you have to figure out what to do with y prime. Well, to figure out what y prime is equal to, you probably want to take this and somehow figure out what y prime is. And the way to use this for y prime is first solve for y, so that if you multiply x both sides, y becomes x times u. And then you differentiate by x both sides. Okay? So what is y prime then? X and u are both functions of x, right? So you should do x u prime using the product rule plus 1 times u. Okay? So using the product rule, you differentiate the second, leave the first, and you differentiate the first, leave the second. Okay? So that's your y prime. And that transformation, that change of variable, works very nicely in any kind of such homogeneous differential equation. So let's try this. Y prime is xu prime, so xu prime plus u equal to 1 plus 2u squared over 4u and then xu prime plus u is 1 over 4u. I can split this fraction into two. 1 over 4u and 2u squared over 4u, which is same as u squared, well, let's write it down, 2u squared over 4u, which is 1 over 4u plus 1/2 u. Okay. So we're almost there, bear with me. And you move this u to the other side, so you get x times, I'm going to rewrite u prime as du dx equal to 1 over 4u plus 1/2 u minus u. So I moved the u to the other side and I wrote u prime as du over dx. And then look what we have. I have a function of u only here, function of x only here. So if I moved dx to the other side and also divide by x and also divide this entire thing to the left side, you've done what? You've separated. Okay. So what kind of differential equation is this? It's a separable differential equation. Separable. So let's do that. Multiply by dx, divide by x, and you want to divide everything here. So, by the way, this is just minus 1/2 u. So if you move the entire thing to the left, you get 1 over 4u minus 1/2 u du. On the right side, it's 1 over x dx. And this is always true. So if you have a separable differential equation, if you have a homogeneous differential equation, if you do that change of variable, putting y over x as u, will transform the differential equation into a separable differential equation. So, and separable is actually the simplest non-trivial differential equation to solve. So that's very good, actually. All right, so let's continue and solve this. I want to multiply 4u top and bottom. 4u top and bottom. So I can cancel this. You have 4u over 1 minus 2u squared du. And 1 over x dx. And when you integrate, See, if you differentiate the bottom, that's negative 4u, which is just minus of this. So I can rewrite this as minus of minus. So that's ln of the denominator. On the right side, 1 over x integrates to ln of x plus c. So I can try to solve for u by getting rid of the ln's. And this is really e to the ln x and e to the c multiplied by e to the c. I'm just going to call e to the c as c. And this just cancels to get you that. And yes?
When you do the for you don't have to do it to the other side as well?
Oh, I'm doing for you top and bottom.
Yeah.
A fraction doesn't change if you multiply the same thing top and bottom.
Okay. And then is that a minus sign under it? You said minus the integral, or is that supposed to be arrow?
So if you multiply 4u top and bottom, 1 over 4u times 4u gives you 1. 4 and 2 reduces to 2. U times u gives you u squared, then there's a minus sign here, right?
Yeah.
And originally I had 4u over 1 minus 2u squared, but I still want to make use of that f prime over f integrates to f, ln of it, the denominator, right? So I looked at the denominator and hoped that the derivative of this is actually same thing as the top. It was almost the same thing, right? If you differentiate the bottom one, you get negative 4u, yeah, and therefore I wanted this minus sign, so I put a minus and put a minus outside. Yes?
When you separated it,
Uh-huh.
what happens to the third u?
Oh, it was 1/2 u minus u is negative 1/2 u.
Oh,
That's what I wrote down here. Any other questions?
It's supposed to be C.
I guess I did the computation a little fast.
It's
Yes.
supposed to be CX or C plus X.
Oh, this is really e to the ln of x times e to the c. I'm calling this as the
Oh,
e to
okay.
c. So it's c times ln of x, so cx. Any other questions?
I think you answered this. Where's the minus u?
Minus u. Oh, minus u. 1/2 of u minus u is negative 1/2 of u.
Sorry.
Right. So it's here. Okay. Any other questions? Okay. And we're still not done. Why? Why are we not done yet? It's in terms of u, right? So you have to go back to it. Okay. Alright, so you still have to solve this for y. How do we do this? Oh, let's see. Subtract. Move this over there, move it here, so you have 1 minus cx equals to 2 times y squared over x squared. So I want to divide by 2 and multiply by x squared, so y squared is 1 minus cx times x squared divided by 2. And I guess you can take the square root, but let's leave it here, because if you take the square root, either this, or equivalently, you can write down y equals to plus or minus square root of 1 minus cx x squared over 2. So that will be another solution.